Welcome and thank you for standing by. At this time, all participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star 1 on your phone to ask a question. I would like to inform all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Katherine Hambleton. Thank you. You may begin.
Thank you and good morning. I'm Katherine Hambleton with NASA's Office of Communications. After standing down on the September 3rd Artemis 1 launch attempt due to a leak in one of the fuel lines, teams have decided to replace the seal on an interface called the Quick Disconnect between the liquid hydrogen fuel line on the mobile launcher and the rocket while at the launch pad. Artemis 1 is a flight test to launch NASA's Space Launch System rocket and send an uncrewed Orion spacecraft around the moon and thoroughly test the spacecraft systems before missions with crew. Here to talk with us about the path forward are Jim Free, Associate Administrator for the Exploration Systems Development Mission Directorate at NASA headquarters, Mike Bolger, Exploration Ground Systems Program Manager at Kennedy, and John Blevins, SLS Chief Engineer at NASA's Marshall Space Flight Center. We'll have a few opening comments from each of our speakers, and then we'll take questions from reporters on the phone. Reporters can enter star 1 on your phone to be entered into the queue at any time. First, we'll hear from Jim Free. Jim.
Yeah, thanks, Catherine. Good morning, everybody. Thanks for making the time to listen and stay interested in where we're headed with Artemis 1. I had two things I wanted to talk this morning. The first is I brought up after on the news conference what we're trying to do with the range and our FTS batteries and the retest requirements that the range has for us. Well, I think there are some things that I probably didn't state clearly enough in the first one. I want to make sure everybody knows that the range has been a great partner in this for us. When we talked after our attempt on Saturday, we were just kind of in the formulation stages of what our plans were. And General Purdy and his team have just been fantastic at listening to where we want to go and giving us their thoughts and us making sure we understand their requirements and concerns. We did submit our waiver package to them to get our retest requirement out there. After meeting with them several times, again, they've been very gracious and understanding of what we're trying to do. I'll reiterate to the fact that our job is to live to their requirements. It is their range, and it's our job to comply with their requirements. So we will do that. Having said that, we're trying to plan a path forward if we're allowed to extend our battery retest requirements on the flight termination system. So to that end, we've asked for a couple dates on the range. To support our planning. You'll hear about the tanking test in a few minutes from John Blevins and Mike Bolger. But our requested dates we put on yesterday were the 23rd of September and the 27th of September. Those dates I mentioned on Saturday that we're trying to work with other NASA programs and obviously other users on the range as well. The 23rd we picked, we're trying to deconflict with the DART impact. The conflict there is use of the Deep Space Network. We want to stay outside of their, I'll say, lockdown of the DSN, which is why we picked the 23rd, so that some of our critical events, if we were fortunate enough to get the waiver from the range and to actually launch on the 23rd, our critical requirements post-initial launch would fall on the other side of the impact of DART on the 26th. So that's how we came up with the 23rd. And then the 27th of September keeps us on the right side of DART, or on the back side of DART, I should say, and then in advance of some other activities on the range that are scheduled for the 30th. There's actually no conflict with anything on the 27th. And then we're looking at a third date, but that is a constraint with Crew 5. I mentioned that briefly. We're just trying to work with the Crew 5 program, and obviously Kennedy, from a consumables perspective, with other activities on the range with replenishment times for the GN2 between launches. So we'll hold to those 2 dates. We'll continue to work with our great partner in the range as they evaluate the realism and feasibility of our waiver request. And certainly if they decide that is not the right thing to do, we obviously will support that and stand down and look for our next launch attempt. But we still will press with the tanking test. So let me turn it over to Mike Bolger and let him talk about the processing going on at the pad and those next steps.
Hey, thank you, Jim, and hello, everybody. Yeah, so I wanted to give you a quick update on how things are going. So since standing down from last Saturday's launch attempt, we've been busy deconfiguring from launch and then working to repair the hydrogen leak that we found during tanking. The repair is basically to remove and replace seals on the 8-inch fill and drain quick disconnect, and then also the 4-inch bleed QD that are both at that flight to ground interface between the LH2 tail service mast umbilical, or TSMU, and the core stage. So to perform that work, we have to demate the LH2 TSMU plate from the flight plate. So there are 2 plates there that come together, one on the flight side and one on the ground side, to gain access to the QDs. Once the plates are disconnected, the workers install transportation caps in the various lines and a plate cover to protect against contamination while we do the work. We're making great progress. Yesterday we completed the plate demate and began inspection of the seals. Following that, we set up an enclosure around the area to protect the hardware from weather and any other environmental conditions while we perform the seal R&R. Regarding the closure, kind of imagine a plastic tent, if you will, that encloses both the workers and the flight plate on some TSMU access stands that we've got out there. So again, kind of imagine a plastic tent, and we've got some conditioned air going in there as well to keep the environment good for the work that we're doing. This morning, we began the R&R, so we've actually got help from our Boeing teammates out there to do that R&R. And if the weather holds up, our plan is to complete both the 8-inch and the 4-inch seal R&Rs by the end of today. Weather could be dicey later in the day, so if that happens, we might just get the 8-inch done. That's something that we'll be keeping a close eye on. If we're able to get both done today, then tomorrow we'll remate the plates ahead of retest this weekend. The retest will be kind of like a mini IVT where we'll be making sure that the data's flowing and that all of our systems are coming up as expected. Following that, we're looking at a cryo demo for verification of the seal. We set a target date of September 17th. Our timeline to get to that is pretty close, so it could, I would not be surprised to see it slip a day or two, but we're targeting September 17th. And that cryo event will be to verify the seal R&R is good. Our preliminary plan is to have the cryo team tank both the core stage and the upper stage with LH2 and LO2. We're taking a look at our procedures and our software now to think about what exactly that would look like. That could ultimately end up being the long pole to get into the test. One thing that we've talked about with the SLS team, really they brought it forward, is a change in our concept of operations to reduce the pressure and flow changes during tanking. So we're calling it a kinder and gentler approach to tanking. We think that may help reduce the stress of pulses or sudden changes on the seals. So big picture, by replacing the seals and going through this cryo event, making the tanking process as benign as possible, we're optimistic that we can knock this problem flat and have a successful tanking. Let's see, from there, we'll determine whether we stay at the pad for a launch attempt in launch period 26 or whether we roll back. I would tell you the team is making great progress. Morale is good. Still excited for this opportunity that we've got. As always, we'll launch when we're ready. You know, we've talked with our team. Last week wasn't our week, but we know our day is coming, and we're excited about it. So with that, I'll close my opening remarks and pass it over to John Blevins.
Hey, good morning, everybody. Good to be with you again. Like to see the progress that Mike's talking about. It's just great out there at the pad. Let me tell you, from an SLS perspective, we continue to look at life-limited items. We've got a list. We look at that very detailed. We performed high-resolution visual inspections of the vehicle as well as walk-downs And so we're working hand in hand with our partners at the ground systems. The state of the vehicle looks good for the next launch attempt, and so we're ready to go. Really encouraged by the fact that it's been less than 1 week since we've had the one scrub that was due to the leak. And it looks like we've got a good plan going forward, as Mike talked about, with the changes in process and everything. I will just add, when you've got two new systems combined like this really isn't out of maybe the norm of expectation in engineering to work those issues. And so I feel really encouraged about where we're at with the vehicle, and we've been able to turn around this one leak issue within a week with a good plan.
Thanks. And so now we'll take questions from those on the line. Those on the phone should press *1 to be entered into the queue. You can press *2 if you would like to be removed from your queue if your question is answered. And again, please state your name and affiliation and to whom you're addressing your question. And of course, we do ask that you limit your questions to one question, and so that we can get to as many reporters as possible. And if we have time, we'll go for a second round of questions. So for the first question, we'll go to Marcia Dunn with Associated Press.
For Mr. Free, when do you expect to hear from the range regarding the waiver, and when do you need to hear from them in order to make late September? And it almost sounds like you're in a hurry to get this going. Why not just wait till October? What are the pros and cons about that? Thanks.
Yeah, thanks, Marcia. As I said, kind of at the end of my remarks, we're pressing for the tanking test. That's in our I guess the forefront for us. We're continuing to look for if the range has questions. Obviously, we'd like to hear from them, but we're following their process. So right now, we submitted the waiver, and we'll look to hear from them on any clarifications that they need from us. When we get closer to the tanking test, obviously we'll have to make a decision after that if we don't have a decision from the range. And then the third part of your question was why not just wait and go to the pros and cons about just waiting and going to October. We need to get the tanking test done, and then we'll have to look at what is the realism and schedule for us for launch periods 27 and 28 based on what we learned from the tanking test and what the team would need to do to roll back if we haven't gotten that waiver from the range, and look at the impacts for 27 and 28.
Thank you. Our next question is from Bill Harwood of CBS News.
Hey, thanks. Bill Harwood here. I'm looking for a little detail on two topics. First, for John Blevins, where are the FTS batteries in question located in the rocket? Are they on one or both stages? And what's involved in testing or recertifying them if you have to? And I'm just wondering what data is available to base an extension on. And a quick follow, if I can. I'm sorry, Catherine. Can you give us an update on where we stand on the SRBs in terms of how long they can be stacked before you guys would have to take some action, and what the issues are there? Thanks.
Hey, Bill. This is John Blevins. I might have all three of your questions out of the one question. First of all, there are FTS batteries that are on each system. So we do have FTS batteries that are on the ICPS. There are FTS batteries on the core stage. There are FTS batteries on the booster. The real heart of the system is the core stage. And so the batteries at question that we're talking about are core stage batteries. They are different than the other systems, and because of their size and mass, they're a little more prone to needing that retest evaluation due to crystal growth. And so ultimately, the batteries that you're really asking about, Bill, are core stage batteries. And so there are three. There's one for every command receiver decoder where you might receive a termination command from the ground and have that set up. And so those actually are kind of the heart of the overall system. And so those are the batteries at question to answer that question there in the core stage. As far as recertify them, I'm really not sure what you're asking, other than we do tests, and then we have battery replacement intervals for those tests. But what we do in conjunction with the range or with our partners there is we do end-to-end testing, right? All the components, top to bottom, to verify things. We do also monitor all of the systems while it's on the pad. So there's some monitoring that occurs passively while we're setting out the pad as well. As far as your question on the SRB stack life, we have for a long time, of course, worked with this material, and so there's numerous data that we can use to bring forward to show the risk, which is minimal, with additional stack life based on slump and other properties of the SRBs. And so we continue to do that to show the risk to the decision makers. That risk is very low, and so that's where we are with the SRB stack life. I think I caught all three of your questions, Bill.
Thanks, John. Our next question is from Kristen Fisher of CNN.
Hi, thank you all for taking my question. My question is about something that Mike Serafin said at the Saturday briefing after the second scrub. He described that inadvertent pressurization of the hydrogen line, and he mentioned at the time that he wasn't sure if that's what caused the hydrogen leak or not. Can you all explain now, do you know if that inadvertent pressurization, did that cause the hydrogen leak on Saturday? And if so, was that human error or computer error? Thank you.
Let's see, this is Mike Bolger. Do y'all want me to take first crack at that one?
Yeah, sure. Go ahead, Mike.
Okay. So let's see, like Mike Serafin said Saturday, we did pressurize the system above the interface requirement that we have from SLS. However, we don't know if that pressure excursion had any effect on the QD. We're still doing that analysis. We know we didn't exceed the hardware design specifications, but we did overpress the system versus that ICD that we've got. So our engineering teams continue to evaluate what happened there. And I talked a little bit earlier about the updated ConOps, about us trying to have a kinder and gentler, if you will, loading process. One of the things that we're really talking about is avoiding pressure excursions. The only other thing I would say is that, after that, our management team apologized to that operator because we had made some manual procedure changes between the attempt on Monday and the attempt on Saturday. So where we normally relied on an automated sequence, we had folks doing some manual procedures, and we practiced it during the week, but they'd only had a couple chances. So we didn't, as a leadership team, put our operators in the best place we could have. We rely really heavily on our cryo team. They really are amazing at what they do. They deliver for us over and over, and I know that they're going to, again, for the next launch attempt.
And I would just add, that's what really we're factoring into getting ready for the tanking test. Charlie Blackwell-Thompson, I keep asking her in meetings like, hey, let's make sure we have enough time for your folks to be ready and practice the loading procedure. So it's front and center for us. And I said to the team, this is we all own the process, and Mike just hit on it well. This is all of us, especially us as leaders, and how far and how fast we're pushing the team. So it was as far as I was concerned, everybody's finger was on that switch.
Thank you. Our next question is from Irene Klotz of Aviation Week.
Thanks, Catherine. Could you just clarify on the FTS if that is a replace or just a retest? And maybe another way of asking the question Bill was asking before is, what do your ground tests show that battery system is good for? Obviously, you already got from the 20 to the 25 days, but how far, just from the ground testing, does NASA think that can be accommodated? And also, what exact date did you put the waiver in? Thanks.
Jim, I guess you want me to take the first cut at some of that.
That'd be great.
So there are retest and replace requirements for any of these systems, right? They have a full useful life. The first one we've been talking about is the retest requirement, like when we go back and we evaluate the end-to-end system. There are useful lives of these batteries as well, so there is a replacement life to the batteries in addition to the retest requirements. We don't bump up against that particular replace requirement within the waiver request. As far as the data, the range is responsible for public safety. And, certainly if we have our sample size of testing, we've got to show confidence beyond that. And that's their call on exactly what that confidence is. I don't want to get into the details of the testing, but we have used similar batteries for much longer than the request. And I say used, I mean tested for longer than the requested time under arduous conditions. But ultimately they have to look at that from a statistical standpoint and make sure they believe the enclosure, the safety is supported with that. But I'll just say the test data shows considerable time beyond the requested waiver for the retest requirements. Once we get to the end of the life of that battery, we replace that battery, and that time isn't just yet. As far as submitting the waiver, we have talked to the range, and part of that is just understanding what they want us to include. There's a lot of things they need to consider. And so there's an initial talk, and we were able to achieve that shortly after the attempt at the scrub last Saturday. So I believe Tuesday morning I was in that call with them and several other engineers, and then we submitted the next day all the data that they need to take a look at. And then I think the formal format of that may have come out just this morning. So the last 3 days has been constant contact of working to make sure that we work with them. And we've done that before. And this isn't the first time that we work with the range. NASA has a long history of collaborative work with that group in order to achieve flight. So that gives you the timeline. I think that was the last bit of the question, Irene.
Thank you. Our next question is from Micah Maidenberg from the Wall Street Journal.
Hey, everybody. Good morning. Mike, you talked about the continuing work on the pressurization a couple of minutes ago. I'm just curious, have any other sort of theories or lines of inquiry emerged about what may have caused the leak on Saturday beyond sort of that pressurization, which has been described as a possible cause, if I'm not mistaken? Thanks.
Yeah, sure. So the teams are still in the field doing the inspections. We'll get the seal out today, and we think we'll learn some more from that. The idea of the kinder, gentler approach is really based on experience, both in the way that Stennis does the green run tanking, and then also as we've reacted to leaks that we've had here at KSC, not just the event Saturday, but other leaks. We've noticed that when we temper the changes, we're better able to manage those leaks when we move more slowly. So we think it's a promising approach to dealing with the issues. Not necessarily going to say that this is endgame, but we think it's promising. And so, again, we're gonna work hard to really try to slow that down. One of the things that we're doing to help with that is we've got some prompts in our automated software where now, as we're kind of transitioning through the various phases of tanking, we can stop when we're going from chill down to slow fill or slow fill to fast fill, and just make sure that we think we've appropriately conditioned the interface and that we've appropriately conditioned the tank. So I wouldn't call it necessarily we're 100% certain this is going to solve the issues, but we do, based on the experience that we've had to date, feel confident that this ought to help us. And let me ask John Blevins if he had anything he wanted to add to that.
Mike, I think you covered the bases really well. I will say that we're NASA, so we do a fault tree, and we look at every possible thing, and then we try to use some engineering judgment to focus on the fault tree links that are the most. And Mike just covered those, right? Whether it's that incident that everybody is focused on, or more generally if you will, the pressure and temperature changes and the rate of change, we're gonna work on all of that. And personally, I think it's more the latter. I think this is just a symptom of putting two new systems together and looking at the flow rate, the thermal mass of the systems, and the pressure changes. And now we have that witness. We have the data. We have the leak, and every time we put it together, we learn a little bit. And I think that kindler, gentler, I think that's a great way to refer to it. I think that is consistent with our history, and I think that's going to be a big win for us, regardless of the reason that we had the leak last week.
Thank you. Our next question is from Gina Sinceri of ABC News.
Good morning. You talked about the 23rd and the 27th being possible launch dates. What do those mission profiles look like on those days?
This is Jim Free. So the 23rd is a 6:47 a.m. window open for an 80-minute total window, and the 27th is an 11:37 a.m. Open to the window with a 70-minute duration.
And how long would those missions last?
Yeah, just one second. And so the 23rd, that would be landing on the 18th of October, and the 27th will land on the 5th of November.
Thank you. Our next question is from Eric Berger of Ars Technica.
Hi, thanks very much for doing this. Just a little bit more about the tanking test. Is that just the fill to like 8 to 10% that you talked about previously? Is it going to be a full tanking now that you're doing, including the ICPS, it appears? Or is this potentially even a full wet dress rehearsal? Just trying to get a better sense of what your plans are for the targeted 17 test. Thanks.
Yeah. Hey, this is Mike Bolger. I'll take first crack at that one. So first of all, the team's still kind of putting the final details together, but the tentative plan that we're looking at is to do a full tanking of both core stage and upper stage. So, through slow fill, through fast fill, through replenish, and so basically that would be not to the wet dress standpoint where we're trying to count down through a terminal count. We're really just trying to prove that we've got a good seal, and so we think this is a good opportunity for us to do it. And given as much setup time as it takes to get into a cryo event like this, it made sense for us to go ahead and practice, again, both core stage and upper stage. It's also simpler for us from the standpoint of less changes to our procedures and less changes to our software. And so, there's a lot of good about it. But like I said, it's not a final verdict, but that looks like where it's headed. That's our tentative plan.
Thank you. Our next question is from Ken Chang of New York Times.
Hi, thank you. Just wondering, are there limits to how many times the rocket can be rolled to and from the VAB? And going forward, so what components will be showing as lifetime limited first? Thank you.
Yeah, this is John Blevins, Ken. I'll take a cut at that to try to explain it well. Certainly, everything on the rocket has some life on it, but when you roll back and forth, and we tend to protect against rolls back and forth, those are complex and that they're kind of fatigue and fracture calculations. It is a very thorough and conservative process. Let me tell you how we got to where we are. What we did is we took originally historic data, right? The first rollout of this vehicle really wasn't so long ago, but you were building it, you were designing it earlier. And so, what you do is you take the information you think you got and you add a little factor to it and you go analyze that. And so what we did, since we have the same crawler transporter, but we have similar to some other heritage events, we took not just shuttle rolls, but we took empty rolls of the crawler transporter or partial stacks. And when you add mass to that crawler transport, you actually attenuate some of that vibration. And so we combined all of that, though, as a spectra, and we give that to the different elements and programs. And then we go in and we try to design the hardware to be certified to a certain number of rolls. Certainly this particular first flight hardware we've asked a little bit more of than we plan on asking out of future flight hardware. But as far as the initial certification was to a certain level that we have not exceeded. We also measured our vehicle rollout when we roll out the first time. I believe it was March 17th. And we had that fully instrumented. And in fact, I had the privilege of walking with the rocket while our loads team was monitoring that info, and we were passing data back and forth to Charlie during that roll, and we hit different speeds. And so that rollout itself was a great test to the system. And so we have that data. The different elements and different parts of the rocket are certified to different levels of rolls. We have not exceeded those, nor will we exceed those if we have to roll back and come back. In addition to that comment, I would like to say, just as far as the process goes, there's not a real known cliff here, right? What you do is you calculate how many rolls that you think you can sustain, if you will, from the critical parts, and then you basically divide that number by 4 so that you can have 4 lives, so that you can have margin to that. And so that's why when we talk about rolls, we want to protect against them, because they are an event. They're a broad event. They affect virtually everything on the rocket. There's other factors that play in, Ken, like for instance, we've got to assume a wind when we roll, right? And so what we assume is that we might be rolling back from even, say, a tropical event. And so we estimate the winds to be in the 47 type knot range at the 60-foot level. And so there's a lot of embedded analysis to cover events, and most of those events have not occurred, and we'd have to go back and do a lot of detailed calculations to give a specific number. If we wanted to, say, clear it for a lot of additional rolls, that would be a lot of work to do that, and it would be constrained by what we assume those events to be, whether those rollbacks are during tropical events or whether there are more benign winds, which is what we've experienced currently today. And certainly those experiences today help add extra life to the vehicle as well. But to answer your question, you asked what would have to be changed. Every element has something different, and it's really about the frequencies at which you roll. And so those do change with the events. And so it'd really be speculative to give you some bolt or some one single component that had to be changed, because if we did go back and we assessed that beyond our certified limit, we'd be looking at the spectra that we have realized and at that time doing the detailed calculations of what we felt was necessary to go in and inspect and either inspect or replace. Let me just add that I do feel confident the vehicle is in good shape, right? And if we need to use rolls, as Mr. Free said, going back, we're going to use rolls. It's something that as the chief engineer I protect against. Everybody in this call has probably heard me say that, just because it is an event for the vehicle that does add just routine wear and tear, and I don't want to do that. And hopefully, Ken, that answered enough of your question.
Thank you. Our next question is from Jeff Faust of Space News.
Good morning. To follow up on Eric Berger's question, if you're going to do a full tanking of the vehicle, both the core stage and the upper stage, is there any reason why you wouldn't do a full wet dress rehearsal, do the countdown down to T-minus 10 seconds or so, just to buy down risk and make sure you understand everything about the vehicle before you do an actual launch attempt on the 23rd or later? Thanks.
Jeff, I guess I'll start, and John may want to add some to it as well. But I mean, really, the purpose of this event is to prove to ourselves that that the seals that we've replaced are good. We have run wet dress attempts, as you know, in the past, and accomplished the goals that we set out to accomplish. The one piece that we're still taking a look at is we may do a pre-press test where we're getting up to flight pressure on the core stage LH2 tank, which we haven't accomplished. That we may add to this cryo event. That's one of the loose ends that we're still talking about. If not, we'll build that into the beginning of our next launch attempt. But other than that, we feel like the prior wet dresses that we've run have accomplished all of the requirements that we intended to capture as a part of those wet dresses, and so we didn't feel like it was needed. John, was there anything you wanted to add to that one?
Yeah, thanks, Mike. Jeff, each one of these events that we do, is just risk buy down and to some degree maybe risk versus risk. And I think Mike characterized it extremely well that, if we didn't have confidence in some of those things that go in there, we probably would do a full wet dress. I think, you might say that it's been piece parted, if you will, a little bit because of the one thing that we didn't get 2, and some of the transitions, they're getting down to T-minus 33. But ultimately, at the end of the day, the full tanking does allow us to take one of those things that we've talked about before and was the reason for the first launch scrub, was the understanding of not just the engine chill process, but how we dial those valves in to hit the terminal count just right. And we need the full tanks to do that. And so it's really a risk versus risk. We don't want to get fully tanked and just stay on condition for a long time unnecessarily, because that could, that would continue to affect the TPS potentially, not to a point where I don't think we're viable, but you just don't want to do things you don't have to do. So it's really about the questions we're trying to answer, as Mike said, and the questions we're trying to answer, some of them could be answered with just a short, fast fill type tanking, but if we want to answer the majority of them, this test that Charlie and the team have devised, I think is a really smart test to do risk mitigation going into the next launch attempt.
Thank you. Our next question is from Joey Roulette of Reuters.
Hey, thanks. I guess this is for anybody who can answer. Besides the hydrogen leak that you guys are looking at, have you found any other issues on the rocket or on the ground system that might require some closer inspection? And then also for Jim, I think, how late can Crew 5 get delayed from October 3rd before the late October launch period for SLS is taken off the table? Thanks.
I guess Mike or John, if you want to take in the first part of that.
Okay, I'll answer from a ground system standpoint. From a ground system standpoint, we are looking clean. We're not working any issues that at this point look like they would be a constraint for us to get into that cryo event. So we're in pretty good shape.
And from the vehicle, it's a similar story. We are always looking at the rocket. Joey, we're looking at the rocket in countdown. We're looking at the rocket, no matter what we do, we'll be looking at the rocket in the cryo demo that we're talking about. But we have no current constraints to a launch attempt from everything we've observed, and we'll continue to look at the rocket.
And then just to follow up on the last part, it's what I said earlier. We're working with the range to hear back from them, and we're focused on the tanking test. When or if we take those off the table are both dependent on those two things. And then just a clarification, the 80 minutes I mentioned for the 23 September, that's 80 minutes where we'll be lit at launch. The total window duration for that is 120 minutes.
Thank you. Our next question is from Nell Greenfield-Boyce of NPR.
Thanks for doing this. So talking with folks who don't follow space all that closely, some people I've talked to are really having a hard time understanding why fueling the rocket on the ground is proving to be so problematic, especially when it's based on technology that was used in shuttle, and we had 30 years of experience flying that. I know you all have talked about hydrogen leaks plaguing the space shuttle, et cetera, but are these seals and these connections like the same as used in the shuttle, or are there significant differences that are leading to things you all haven't seen before? Thank you.
I guess I'll start and then maybe let John Blevins. They don't let me do technical stuff anymore, so I'll let John Blevins take the back end of that. I guess I think Mike Serafin and I talked about the difficulties with hydrogen and getting the configuration right. And the fact is, shuttle had these problems after 9 years of ops. So and this is the first time we're operating this vehicle, and I think you can say from other launch vehicle development throughout the years, there are challenges when you try and do this. I think the statistics prove that for Apollo, if I just make the Saturn V comparison, leaving aside the commercial vehicles that have had challenges trying to get to their first launch. So John will fill you in on the technical side of it, but from my perspective, it is we're doing this, and it's part of the process and part of what has proved to be the similar issues on other launch vehicles the first time you process them. Go ahead, John.
Yeah, thanks, Jim. Neil, it may look a lot the same, from a long distance. If we had a shuttle out there, you'd see quite a bit of difference in terms of size for sure. As far as this tanking system, every system is unique. There's some things that we did on shuttle that cost us some mass. It was a totally different tanking system, totally different propulsion system, lines, ducts, and valves, that is, not the actual engines. But, the volumes are different, the pressures are different, the rates of change are different, the seals are different on purpose. It's a design feature. It's not a problem. We will actually get to a very operational status, I believe, very quickly. It's been less than a week since we had the one scrub due, not only scrub due to the leak of hydrogen. Shuttle did get operational. Certainly, there's no question that hydrogen is a challenging molecule, but it's worth it. Hydrogen is the highest performance molecule, and if you look at the mission we're doing, this mission begs to use this fuel. It wants that sustainer, high ISP performance that you get out of really what is the most high-performing rocket engine on the planet, and that is these RS-25s. No questions asked on that. And so the reality is that we will get to an operational status, in my judgment, and that this really isn't out of the norm of expectation. We've changed our process several times as we've gone through the minimal tankings we've done. You can count this on your hand, how many times we've done this between these two systems. And so I really not discouraged about it at all. We do have different pressures, temperatures, and rates of change than shuttle, and we're dialing that in. And that's the part that Mike talked about earlier that is so crucial, that the teams between Boeing and SLS and ground systems are just working together on. And I am very encouraged by the data that I've seen in the last 48 hours and the plan ahead. And so yes, now it is different. And I think we're going to get that system nailed down in short order.
Thank you. Our next question is from David Curley of the Discovery Channel.
Thanks very much. Mike Bolger, can you tell us about the inspection of the seals? What did they see? Were they in normal shape? Were they ripped? Were they torn? What did they see when they opened up and got the panels off?
Yeah, at this point, we've just gotten a first look. There was an indication on the 8-inch seal. We saw a very minor, I'll call it notch on the 8-inch seal that the team will be taking a lot deeper look at in the hours and days ahead. 4-inch didn't see much. So at this point, again, very preliminarily, there is something to take a look at on the 8-inch, and the team will be looking at that more deeply as we get it out. At this point, it's still actually on the flight interface, so we haven't been able to. Well, as of 8 this morning, we're in the process of replacement, so it may be out now. But the team will take it out and do a more detailed inspection of that entire seal here soon.
Thank you. Our next question is from Chris Gabehart of NASA Spaceflight.
Hi. Yeah. Wondering, just going back to your point about the launch window on the 23rd, and you very specifically only mentioned the 80 minutes of the window that we're in daylight. Are you ruling out lifting off at night for SLS on its first attempt based on that comment? Or is the whole window that day available and they can launch at night if the rocket's ready to go at the opening of the window? And also for this LH2 umbilical leak, I'm wondering, you've gone to fuel this vehicle 4 times now with LH2, and you've had an LH2 leak on the TSMU each time, or one time actually a repeat. Is this potentially indicating that there's something with the TSMU itself and the design, like that's dragging some of these lines down and creating these potential demate scenarios of the seal that you'll need to look at before Artemis 2? Thank you.
Yeah, this is Jim Free. I'll take the first one. No, the 80 minutes, that's just an error on my part. So the 120 minutes is available to us, and if the team decides we want to use it all, then we'll use it all. I think we'll make that final determination when we get close, but we're not ruling it out right now. And then I guess Mike Bolger is probably the second one's for you.
Yeah, I think with any first flight, when we get to the backside of this and have a successful flight, I think you've heard us say that we think we're on the brink of that. We'll step back and we'll take a look at our ground systems designs. We'll take a look at I know John and team will take a look at the flight systems designs, and we'll see if there's anything that we think we ought to do differently. We do test these interfaces extensively at what we've got a facility called the Launch Equipment Test Facility, where we basically have a mock-up of the TSMU and of the flight plates, and we do extensive testing. We felt comfortable coming to wet dresses and coming to launch that we had a good system. Clearly we have had some leaks. I think like others have said, there can be a lot of things that drive that. We've got new procedures, new software, new flight hardware, and new ground systems, and we're going to be taking a look at all of those things to see if there's something that we can learn ahead of Artemis 2 so that we don't have these kind of problems recur.
Thank you. Our next question is from Stephen Clark of Spaceflight Now.
Hi, thanks for taking my question. I want to follow up on Bill Harwood's question earlier about the booster stacked life. John, you said there's minimal risk of that being an issue right now, but is there a point in the coming months where that does become more than a minimal risk, and when is that point? Basically, how long are those boosters good for, according to your current analysis? And I'd also like to ask maybe Catherine or Jim, do we get an image of any of these quick disconnects, even a generic type image of what we're talking about, or maybe an image of the enclosure approved for public release? Thanks.
Hey, Stephen, the first part of that, I hate to give you a disappointing answer, but the answer is I'm not really sure, just because I'm working on a few other things and looking at those things. Certainly we can try to get back with you, but, for me, what happens when we have a stack life and we know that we've got a certification for stack life, they'll bring me and John Honeycutt, our program manager, a waiver for us to look at with evidence of why we're good to continue to the next milestone, to the next point. And so I don't really have the data at my fingertips to say what the real stack life limit would be. Certainly, it's about structural integrity of the booster, and we know we have enough data to be out there now. And certainly, we're not going to go beyond what Northrop Grumman provides us for information that's solid on the stack life. So I guess from my perspective, we know we've got it now, and we know that we won't do anything that compromises that integrity. But I'm certain that we've got a few more months left in the stack life.
Thanks, and we can work on an image of that for public release. All right, our next question is from Tarek Malik of Space.com.
Hello, thank you. Yes, my question is for Jim Free about the waiver, and I apologize if I missed this earlier, but exactly how long of a waiver or extension are you looking for with the range for the FTS check system? Is it just through the 27th attempt? Is it through the October 31 window for period 28? If you can add some clarification for that, that would be great. Thank you.
Yeah, Tarek, no, you didn't miss it because I didn't say it. I want to be very respectful of what the range, and by talking about it here, even just on Saturday, I think they felt like we were kind of going outside the process, and I don't want to do that. So I really don't want to talk about the total duration that we're looking for, because that is something that is for us to share with them and for them to determine. So throwing that out there, I think would be a process foul for me.
Thanks, Jim. Our next question is from Marcia Smith of Space Policy Online.
Thanks so much. I'm just trying to get some clarity on the likelihood of the launch on the 23rd or the 27th. So you said that you're targeting the tanking test for the 17th, but that might slip a day or two. So if that slips a day or two, does that rule out the 23rd? And you're not quite sure when you're going to get an answer from the range. So how close to those dates can you wait? I mean, can the range tell you on the 22nd and you can still go on the 23rd, or what does that timing look like?
I mean, I'll give my thoughts, and then Mike Bolger can kind of weigh in from a processing time. No, I mean, we can't wait till the 22nd. I think that's why we have a set of processes that Charlie and the team have to go through and back that time up. But right now, we feel like there's enough spacing between that tanking test and an attempt on the 23rd if we were to get the waiver. But Mike, I don't know if you have anything to add.
Yeah, no, Jim, I agree. I mean, initially we felt like we needed at least 4 days between the tanking test and between launch. So if it slipped off the 17th for a couple days, I think we could still protect the 23rd. So yeah, I think we're still okay. Obviously, there's a lot of work to do between now and then, and our plans could change. But at this point, we think we need at least 4 days.
Thank you. Our next question is from Liz Hurley of WAFF-TV Huntsville.
Good morning. Can you hear me?
Yes, we can hear you.
Follow up to my question Saturday. The cost in real dollars to 2 scrubs and the cost of public confidence. The answer couldn't come on Saturday, but I'm wondering if you all have the answer now. And to Dr. Blevins, you told me 3 weeks ago in Huntsville that your confidence level was high at the time. Nothing was keeping you up. You had crossed off your checklist. Today, you all are saying you're not 100% confident that you've been through the fault tree and that the R&R will do the trick for the 23rd. What is your confidence level going into tanking and the 23rd for launch?
Yeah, so I'll start, and I'll probably give you the equally unsatisfying answer from your perspective that I gave you, and then I think the administrator said it best when the cost of failure is much higher than the cost of scrubbing, and I can't say it better than that. We have an obligation to get this right, and if we fail on this mission because we didn't do everything right, then the cost would be incredibly high, and we're doing everything we can to get this right. And as I said the other day, right, we have the people on the mission working it. We have the assets that we own as part of what we do for Deep Space Network and the Space Network itself, and what we're really using is the consumables are the hydrogen and oxygen, and we recover part of that. So we're not bookkeeping it that way right now. We are looking at the future as trying to get to a per mission cost, but we're not there right now. And John, I'll let you handle the other part of that.
Yeah, thanks, Jim. Liz, I'm still sleeping well at night, and the team is working very hard to fix the things that have impeded the launch, as you said. There's a lot more to flying a rocket than launching. Certainly, we've been held up. To speak to that and the confidence there first, I've mentioned it's a new system. I used to design cars a couple of decades ago, and even whether it's a car or a minor overhaul of a design, there's a lot of issues you work through when you put a system together, and those take time. And you guys are going on that journey with us. And I know right now that may lower your confidence. I get to see the inner workings of this team and where we're at, and I feel real good about the ability to pivot and solve the problems that we encounter. As far as the rest of the mission, we have a great architecture. Honestly, this architecture is really fit for this mission. We need high reliability. We're going out into deep space. This is not, driving to the grocery store. This is a mission like you're about to sail into unknown territory. And I feel like we've got the right architecture, the right machinery. It's all been proven to work pretty well. Our first flight's not behind us, and that hasn't changed. And I feel very confident that the teams will solve the problem that's keeping us from a launch, and I feel confident that the hardware will perform as designed. So I still have very high confidence in this machine.
Thank you. We've got time for 1 or 2 more questions. We'll go to Doris Arupia from Inverse.
Hi, thank you so much for taking my question. So I'm curious about the
the impacts of weather on all of this. We did see a few lightning strikes before the first launch attempt. We are in hurricane season, and as the U.S. has experienced a major heat wave, which I'm sure contributes to the strength of some of these storms. So as Artemis 1 is now spending a big chunk of this time on the launch pad, I'm wondering how you are mitigating risks from the weather and maybe just general explainer on, even without all of the work you're doing now to test tanking again, what typical procedures would work in this range, to launch during this beginning of hurricane season. Thanks.
Let's see, this is Mike. I can talk to that a little bit. So regarding, clearly it's Florida summer, and it's a season where we tend to have thunderstorms, particularly, or more commonly at least, in the afternoons. And so it's something that we have to pay attention to, and it's something that we're paying attention to this week as we're doing this seal work. We're fortunate from a lightning standpoint. We've got a terrific lightning protection system out at the pad. You've seen the three 550-foot towers that we've got out in the catenary wire that so far has proven really effective in protecting the launch vehicle through a couple tough storms where those towers did take strikes and again protected the vehicle extremely well. In fact, we have so much confidence in those lightning towers that we do allow people to work when we're in a phase 2 lightning storm if they're underneath the protection of that lightning protection system. So from a lightning standpoint, we're confident. We think the system has proven really effective. From a thunderstorm standpoint, we're going to be taking a look this afternoon. We're going to get through this 8-inch seal this morning. Hopefully they're getting through it around now, and we're going to take kind of a 4-hour look ahead. And if we feel good about the 4 hours that we've got in front of us, we're going to go ahead and we're going to do the 4-inch seal. If the forecast is showing us, though, that there's a high likelihood that we're going to have some thunderstorms rolling through the area, then we'll probably wait until third shift tonight when those things typically calm down and come back third shift and make another run at it. As far as tanking and launches, there's a pretty detailed set of weather criteria that we take a look at. I don't have it all in front of me, but basically, we want to make sure we're not going to have we're going to have less than a 20% chance of lightning during the period where we're tanking. We're not going to launch through, layers of clouds and so forth. We would have to get you more detail on what all of the requirements are, and then, your last part, pointing out that this is the peak of hurricane season. We do keep an eye, out particularly in the Atlantic this time of year and watch the storms. I saw yesterday's report, and we were still looking pretty clean for the immediate future. We'll continue to pay close attention to that, and if that changes, then we'll get together and we'll talk about whether we've still got the right plan.
Thank you. And Doris, we do have the weather criteria for roll, tanking, and launch as part of our press kit online. So that's all the time that we have for questions today. Thank you all for joining us. You can listen to a replay of this teleconference online by visiting the Media Resources tab at nasa.gov/Artemis-1 later this afternoon in about an hour. I know we weren't able to get to everybody's questions, so if you do have questions that we weren't able to answer today, please reach out to myself or one of the other public affairs officers on our team. And you can watch a live stream of the rocket on the pad at the KSC Newsroom YouTube channel, and you can follow along and learn more about the mission at nasa.gov/special/Artemis-Roman numeral 1, and that's all lowercase letters. So thank you all for joining us today, and have a good day.